Imagine a pillar of fire, reaching for the heavens. The ground trembles, the air crackles with energy. This is the power of rocketry, a force that has propelled us from Earth and into the cosmos. From the earliest fireworks in ancient China to the towering rockets of today, humanity has always been driven by a desire to explore the universe beyond our world. Rocketry is the key that unlocks the cosmos. It allows us to break free from gravity's grip and venture into the unknown. The story of rocketry is a tale of ambition, ingenuity, and relentless human curiosity. It's a journey that has taken us from tentative steps to giant leaps, constantly pushing the boundaries of what's possible. Early experiments with gunpowder in China hinted at the potential of rockets. These simple devices, propelled by the explosive force of gunpowder, laid the foundation for centuries of innovation. But it was the 20th century that saw rocketry truly take flight. The development of liquid-fueled rockets by pioneers like Robert Goddard revolutionized the field. Goddard's groundbreaking work in the 1920s and 30s paved the way for the powerful machines that would eventually carry humans to the moon and beyond. His rockets, fueled by a potent combination of liquid oxygen and gasoline, demonstrated the potential for controlled, sustained flight. Robert Goddard, a visionary often ahead of his time, faced skepticism and even ridicule for his ideas. Nevertheless, he persisted, driven by an unwavering belief in the power of rocketry. His work lay dormant for a time, only to be dramatically resurrected during the tumultuous years of World War II.
I knew that the dream of reaching space was possible even when others doubted. My conviction never wavered.
On the other side of the Atlantic, a different kind of rocket was being developed, one born from conflict and driven by war. The German V-2 rocket, a terrifying weapon of war, also represented a significant leap forward in rocket technology. Under the leadership of Wernher von Braun, a team of German scientists and engineers developed the world's first ballistic missile.
The V-2 was a marvel of engineering, incorporating advanced rocket engines, guidance systems, and fuel technologies. Though it was used for destruction, it laid the groundwork for future space exploration.
The V-2's impact on the future of rocketry cannot be overstated. Its development served as a crash course in rocket science, providing valuable data and experience that would fuel the ambitions of both the United States and the Soviet Union in the years to come. In the aftermath of World War II, the world was a changed place. Two superpowers emerged, locked in a tense ideological and technological struggle: the Cold War. This rivalry extended far beyond Earth, as both the United States and the Soviet Union recognized the strategic and symbolic importance of space exploration. Thus began the space race, a period of intense competition and innovation that would redefine humanity's relationship with the cosmos.
The Soviet Union struck first, launching Sputnik 1, the world's first artificial satellite, in 1957. This small, beeping sphere sent shockwaves around the globe, signaling our early dominance in space.
The United States, caught off guard, redoubled its efforts. NASA was formed in 1958, consolidating and accelerating American space ambitions. What followed was a breathtaking series of achievements. Astronauts like Yuri Gagarin, the first human in space, and John Glenn, the first American to orbit Earth, became global icons, embodying the daring spirit of the space race. But the ultimate prize remained: the moon. President John F. Kennedy's bold challenge in 1961 to land a man on the moon before the decade was out galvanized the nation and set in motion one of the most ambitious scientific and engineering endeavors in human history: the Apollo program. The Apollo program culminated in 1969 with Neil Armstrong's historic first steps on the lunar surface. "That's one small step for man, one giant leap for mankind," Armstrong famously declared, his words echoing the profound impact of this achievement on human consciousness. But even as the world celebrated this triumph, engineers and dreamers were already looking beyond the moon, envisioning a future where space travel was not an extraordinary feat, but a routine occurrence. This vision led to the development of the Space Shuttle, a partially reusable spacecraft designed to make access to low Earth orbit more cost-effective and routine. The Space Shuttle, with its iconic winged orbiter, became a symbol of American ingenuity and technological prowess. Over 3 decades of service, the Space Shuttle program achieved remarkable feats, launching and repairing satellites, deploying the Hubble Space Telescope, and conducting groundbreaking scientific research. The Space Shuttle program wasn't without its challenges. The tragic losses of the Challenger in 1986 and Columbia in 2003 served as stark reminders of the inherent risks of spaceflight. Yet through these setbacks, the program persevered, demonstrating the resilience of the human spirit and our unwavering commitment to pushing the boundaries of exploration. The Space Shuttle era marked a significant transition in space exploration. It moved us from the realm of singular, historic missions towards a future where space travel was increasingly viewed as a sustainable and achievable endeavor. The Soviet space program, though often shrouded in secrecy, achieved remarkable feats of engineering and endurance. Section 5. Beyond Earth's Embrace. The Soviet and Russian Legacy. While the United States focused on the space shuttle, the Soviet Union was quietly developing its own spacefaring legacy.
We also pioneered the concept of long-duration spaceflight with our Salyut and Mir space stations. The Soviets were the first to place a human-made object on another celestial body with the Luna 2 mission in 1959.
These orbiting outposts served as platforms for conducting scientific research and testing the limits of human endurance in space. Following the collapse of the Soviet Union, Russia continued to play a pivotal role in space exploration.
As a key partner in the International Space Station, Russia has made significant contributions to the development and operation of this orbiting laboratory, a testament to international collaboration in space.
From the earliest days of Sputnik to their enduring presence in space, the Soviets and Russians have left an indelible mark on the history of rocketry and space exploration. Section 6. A New Generation. SpaceX, Blue Origin, and the Privatization of Space. The 21st century ushered in a new era in space exploration, one marked by the rise of private companies like SpaceX and Blue Origin. Founded by visionary entrepreneurs Elon Musk and Jeff Bezos, respectively, these companies have injected a new dynamism into the space industry.
SpaceX, with its focus on developing reusable rockets and spacecraft, has revolutionized the economics of space travel. Our Falcon 9 and Falcon Heavy rockets, capable of landing vertically after delivering their payloads, have significantly reduced the cost of launching cargo and humans into orbit.
Blue Origin shares a similar vision of making space more accessible. Their New Shepard suborbital spacecraft offers tourists the opportunity to experience the thrill of weightlessness and gaze back at Earth from the edge of space.
These companies, driven by a combination of technological innovation and entrepreneurial spirit, are pushing the boundaries of what's possible in space exploration. Our efforts are opening up new possibilities for scientific research, commercial ventures, and even the eventual colonization of other planets.
Section 7. Global Reach, ESA, ISRO, CNSA, and the Expanding Frontier. The pursuit of space exploration is no longer limited to a handful of nations. Agencies like the European Space Agency, the Indian Space Research Organization, and the China National Space Administration are making significant contributions to our understanding of the cosmos.
ESA, a consortium of European nations, has a long and distinguished history in space exploration. From developing the Ariane rocket family to launching probes to study distant planets and comets, ESA continues to play a vital role in advancing our knowledge of the universe.
ISRO has emerged as a major player in space exploration, particularly with its cost-effective and innovative missions. Their Chandrayaan and Mangalyaan missions, which sent orbiters to the Moon and Mars respectively, have showcased India's growing capabilities in space technology.
CNSA has made remarkable strides in space exploration in recent years, landing rovers on the Moon and launching their own space station, Tiangong. These achievements highlight China's growing ambitions and capabilities in space.
The increasing participation of these and other nations in space exploration underscores the global nature of this endeavor. It's a testament to the universal human desire to explore, discover, and push the boundaries of our understanding of the universe. Section 8. Innovation ignites next-generation rockets and technologies. The future of rocketry is brimming with potential. Engineers and scientists are constantly pushing the boundaries of what's possible, developing new technologies and designs that promise to revolutionize space travel. One area of intense research is the development of reusable launch systems. Companies like SpaceX and Blue Origin are leading the way with their Falcon and New Shepard rockets, respectively. But other innovative concepts are emerging. Another exciting area of development is the exploration of new propulsion systems. Traditional chemical rockets, while powerful, are limited by their fuel efficiency. Researchers are